Good evening, Diane and Norlin. And today I've just sent you about an email about our course materials for tonight and for last week courses, and also with the recording of the class in the last weeks, so you can remind or you can add for your self-study. And now for this events tonight, we will continue about our data analytics. And the topics for tonight is about relationships. It's taken for our textbooks and for the chapter 10 and 12. What is the meaning of the relationships? We still continuing about our last meetings about the inference in statistical analysis or in data analysis. And before we start about the relationships, we need to explore about the function of regression analysis using the estimating about the relationship between variables. As we learn in the analysis, like the regression analysis is taking a study about the relation between the variables. If you looking for the meaning of the variables, it is something that you can measure, you can observe. It's maybe it's directly or using an indirectly using the proximity, but they are having a potential objective to be measured for analysis, and using these variables to create some predictions. The variables or the relationship about among the variables is basically comes from the two types. It could be a cross-sectional data using the data gathered from the time of populations with a specific of populations, and then about the time series data. The time series data is could be containing more than one variables, or you just have a one variable, that's okay, but you have a several time, or we have the sequence point of time of analysis, like the several years analysis, or they having the making some connection. We call it about the auto correlation between the series or the time of the data. That kinds of time analysis or time series data. So in for regression analysis, we should be concludes or categorize the variable in the two area. The first one is about the dependent variables. We call it dependent because it could be to trying to be explained or predicts, and it's sometimes they are having different terms like the response variables or target variables, but they are the same. It could be a dependent variable. Another variable, sometimes we name it independence as the opposite of dependence, but in actually they are kind of the explanatory variable. The explanatory variable, it could be having an independent positions, so sometimes they call the independent variables. And also we have taken for the predictor variables or the factorial variables. So we have two kinds of the regressions in here. If you have only one explanatory variable or the single explanatory variable, we call it a simple regressions. But if you have more than one or the several of explanatory variable, we call it the multiple regressions. That is the meaning of regressions as, and the step or the kind of the regression analysis. Starting about the regression analysis, we need to creating some graphical analysis using the scatter plot to compare about the relationship between our variables. We have comparing in the two axes, the x and y, maybe in mathematics, and should be apparent for the scatter plot or the kind of the plot. For example, like here, we have some data using the three variables: the machine hours, the production runs, and the overhead. You can look at it for here. This is the first variable, the machine hour. The second variable is production runs. And the next variable is the overhead. So 1, 2, 3 of variables could be combined in the relationships, maybe between the machine and productions. We also comparing about the machine and overhead. And once of a pair, we can compare about the productions against the overheads. That's the combination in our relationships. The machine, the productions, and overheads. When we're looking for the scatter plot, it could be like this one. We can comparing about the axis of X is about the overhead compared to the machine hours. This one is the overhead and is the machine hours. And we have to comparing about the overhead and the productions runs. So if you find about the plots like here, the combination of here, you can make creating some trend analysis if you can. But sometimes the pattern is could be unpredictable, like this ones. For the overhead and production, it could be like this one pattern. But in the overhead and machine hours, it should be it's very tight. It could be like this one, or it could be with this one. So there's a difference visions about our eyes, our analysis that could be indifferent between the scatter plots. In a time series analysis, we can find about the graphical or line chart like here. We have the a series about the overhead and the machine hours and the production runs. The mapping is very, very random. So it could be predict using the usual pattern. If we find about the prediction about the relationship and we cannot conclude in a pattern, we can separate the analysis using two kind of the independence of detections, like the linear and the non-linear. What is the meaning of the linear? Linear, it means that you can see a straight line, like the previous of our analysis, but you cannot see about the straight line. It could be a non-linear. Look at for this scatter plot. If you follow about the patterns, it could be not a straight line. It could be a non-linear. The straight line is could be like this one, or maybe this one, or maybe this one. That's a straight line. But we have the parabolic line like here. It concludes in the non-linear relationships. So before we start the analysis, you need to know about the pattern of your data. Sometimes our data is contained about the outlier. What is the meaning of outlier? Outlier is a kind of observation that should be fall outside of our patterns. If you can create with some straight line patterns or with the linear analysis, and then your observation is outside of, it's true away for your patterns, it could be an outlier. It could be clearly for your patterns. Look at here, when we found about the patterns, if you have the containing data like here, we can create a pattern like this one. But the one data is fall outside of our pattern. That's called outlier. Okay, the outlier is containing in our data, but if the number of outlier is still low or just a few of outlier, it cannot be break our data or cannot mistaken about our interpretations. But if your outlier is very, very high, or in a maybe half of your data, it could be make your mistakes in our interpretations. So Then the outlier sometimes should be interprets or you can make some exclusion for your data. If you find about the data with the pattern like this one, it could be categorized as unequal variations or invariance because we have the different conclusions about the variance of analysis using in the below standard and over the standard. Look at with the timeline analysis like here. So it could be separate below the line and under the line like this one. Okay. When you find about your scatter plot like this one, it makes some maybe with the rational patterns, it could be predictable like this one. You can find but oh, it may be with the line pattern like this one. Okay, but it cannot be a single patterns. It's lots than a patterns. We cannot conclude like this one patterns or maybe with this one pattern. So this is the indication about there is no relationship between our data because the relationships cannot be appears in a patterns. They are very randoms and could be predicted. That is why we need a correlations to predict our strength about the data. The correlations mean that there is the score is indicate about the strength of our linear relationships between the pairs of the variables, between your axis, x or y axis. And the strength of your variables, it could be separate between 0 and 1. That is the range of our correlation score. If your score equal to 0 or near to 0 is practically it's simplified as no linear relationships. But if your correlation is close to 1, it could be indicated as a strong linear relationship. If you have the 1-point score of relationship, it should be a perfect relationship. It could be in a negative correlation or in a positive correlations, but there is a perfect correlations. But it's still close to 1. It's just indicate a strong relationship. Okay. The linear regressions, we have two kinds of verifications with the name of the simple linear regressions and the multiple linear regressions. What is the mean of the simple regressions? The simple regression is containing about a single explanatory variables. You only have one predictions variable to predict your dependent. So we have to be comparing about the kind of regressions between the single and with the multiples. How we can compare the strong or the best fit model for our regressions. You can use about the symbol of R square. Maybe this is not unfamiliar in your statistic. R square is very important measure to comparing about the goodness fit of your data. What is the meaning of goodness of it? It could be predictions about your explanatory variables can be predict about the dependent variable in a regression analysis. It could be in 0 and 1 or maybe in 100%. So it's better for the linear fit is closer to 1 or maybe is close to the number 1. So the correlation between the dependent and explanatory variable explain or expressed in the R square score between 0 and 1. So in the multiple regressions, we also find about R square, but it's containing several explanatory variables, not only in a single explanatory. So you can make some graphical and they have the comparison score using the R square. What is the meaning of best fit modeling? The best fit modeling is your models or the regression analysis having a higher R square. It's closest to 1. but sometimes we found the kind of regressions that containing with these interaction variables. It could be in a dummy variables, the interaction variable, and using the nonlinear transformations. So the R square could be having some mistake if containing about the three kind of regression equations. What is the difference about the variables? The dummy variables is containing about the variables that only indicate, only scored using two kind of data, 0 and 1. Like your gender, maybe 1 for male, 0 for female, or in opposites. Or maybe in the your score of your exams, you can pass or fail. Just only two predictions, just only two score to combine about the situations. Look at this data. If you find about the kind of variables like this one, the kind of number of employee, the kind of education, the kind of grade, the years and the age, gender, and job and salary, we can find about the dummy variable, or you can conclude a dummy variable using the classical categorical. Where's the variable that could be uh, separate in two category? We can find in here the busy job. It could be uh, answering in two kind of positions, yes or no. You can classify yes for one and no for zero, or in opposites, yes in zero, no for one. And also we have a gender because we have the category male or females. That is the kind of combination using the dummy variable in our data. So we can include this qualitative data to our analysis using the quantitative data. Next, for the interaction variable is containing about the explanatory variable that have an interactions between another explanatory variables. So you have more than one of explanatory variable that could be correlates. It should be make some mistake in our analysis using the regressions, because the normal indication of our regression analysis for predictions is there is no relationships between our explanatory variable. If your explanatory have some interactions, that could be a misunderstanding for your regression analysis. Look at for these patterns using the female salary and male salary. We found about the break-even point in here. So in these ones, before they separate in the difference analysis, we can use this kind of data, but not in the below of the break-even data, because there are different patterns between the female salary and male salary. So you need to break down this data and create some regression analysis in two kinds of the data. The next classification is about the nonlinear transformations. If you find about your variables and having the pattern is not in linear, maybe in a parabolic, or maybe in the logarithms, or maybe in the reciprocal analysis, you can transform your nonlinear variables into the linear. You can use the dummy, maybe you can use about another transformations. Like these ones, you have the cost and the unit analysis. We have the kind of scatter plot like here. It could be linear analysis using these patterns, but if you look it with the clearly, we have two kinds of analysis. One people see this is like a parabolic or logarithmic transformations, but the other ones using looking this one is like on linear regressions. So they have two kinds of visions and could be having some mistake in the regression analysis. Here's the A great point. How to estimate a relationship using the regression analysis. Before we start to the next chapter, any questions for Diane or Norlin to be clear before we continuing our materials?
Sir, I have a question with
Yes, Diane.
regards to outliers.
Okay.
Uh, you said earlier that if there are only minimal outliers, it doesn't really affect our analysis. So we can disregard it. But what if there are a lot of them? I mean, if there are many outliers, how do we treat them?
Okay, that's a good question about the outlier. Our data is also containing about the outliers, but the kind of outlier, the number of outlier is different. Sometimes we have a few outlier and it cannot misinterpreting about our data. So be it, ignore it. There is no problems. But if you have lots of outlier, your interpretations could be a mistakes. So what is the main point of how to face about this outlier? You need to know the percentage of outlier in your data. If maybe several in 5% of 10% of your data, it sometimes is there is no directional effects in your data. Sometimes it doesn't have some any effects to your predictions. But if more than 10% of your outliers containing in your data, you need to eliminate your outlier. For example, like this one, if you have 100 of observations and the 12 of your observation is an outlier, like this one. Maybe if I have 100 students in my class, 12 students having the zero score or they are having no good score, it's below the standards, but the rest of the students, 88 students, having a great score. So if you combine your data with the 12 student there is a bad score, your average score will be affected. The average of class will be affected to be going down, but you need to eliminate the 11 sorry, the 12 of your students to make some grade on average in the class score. So if you can calculate about the percentage of your outlier, Diane, is you can make some justification. This is a high or not. It's a few or you can use it in your data or you can eliminate your data. For the better suggestion is you should throw away or eliminate your outlier. But it's only one or two outlier, that is okay. You just ignore the outlier. Is it clear for you, Diane?
Yes, sir. Thank you very much. Now I understand it. Thank you.
Okay. Okay. In your maybe in your final projects or in your thesis for your graduate students or undergraduate students, you have some empirical data, and your empirical data might be using the reports of the data or maybe with the questionnaire. It's containing about the outlier, so you need to be careful about the outlier. Please ensure that the number of your outlier is maybe below 1% or below 5%. There is no problem for your analysis. Okay, let's continue about our material using the time series analysis and about the forecasting. The forecasting is a very difficult task because what we predict, what we want to forecast, it could be having a great accuracy or maybe in a bad accuracy. So it's separate in the short run or the long run. But the pattern is not easy to be undercover. There is no guarantee about our forecasting analysis. So many forecasting methods it's available for your analysis. Maybe in the finance analysis or maybe in your political analysis in our country, in your country also have been divided into three groups. It's containing about the judgmental methods, or sometimes we have the extrapolations using the pattern in the several times of series data. or maybe for econometric or the causal methods. So the first method is non-quantitative, using the judgment. It is purely for your judgment. There's no effect for the number or no suggestion about the number. Okay. What is the meaning of the extrapolations using the series analysis? You can make some forecasting or predictions using the trend-based analysis. You need to know about the pattern of your data using the scatter plots, and you can see about the pattern. It could be growing up or going down. Or you can make some auto regressions and the moving average expression, or using the exponential smoothing. But be careful about the exponential, because the exponentials is sometimes the prediction is over than our analysis or our predictions. The next of models is kind of the econometrics model. The econometrics model is containing about the lacks of data. What is the lack of data? There is we have the several patterns that could be not included in our data. That is the name of the lag. So the data should be not correlate between the series. So we need to ensure that we have no autocorrelations about our data. If you have the autocorrelations, your prediction doesn't happen, because there is no predictions, because your data is automatically correlate with the past data. So how we combine about our forecasting analysis? The forecasting analysis is combining in the two kind of the data. Sometimes we combine about the simple analysis and combine with the general analysis or weighted analysis. For the simples, we can use about the component of the time series data. It could be with the trend. That's very simple. You need to know about the separations of your plots or separation of your data, and you can creating about this is linear or non-linear. For the graphical A, it could be a linear because it should be a straight line. But if your data is like this one, and the graphical number, the B, this should be a exponentials, because the growing is so fast. And then for the graphical C is about the S-shaped trends. They're having a peak performance, and then they're having a cutting down of the performance. Sometimes you also find about the data seasonals like this one. What is the meaning of seasonals? You can knowing about your patterns. Sometimes it's going up, and after up is going down. After down is going up again, and then it's going down again, and up again, and down again. This is the same seasonal patterns that could be repeated in your analysis. It could be in the strike line like this one, or maybe in the good line analysis like this one, with the trend and without the trend. And the next of our simple regression is could be a cyclical components like this one. What is the cyclical component? It's similar with this one components with the seasonality. It could be the occurrence of our data could be predicted with the after the first season, the second seasons, or maybe the first year, the second year, and also with the kind of the actual data using the prediction within the between your axis, the x-axis and the y-axis. However, if you have some pattern and you cannot predict your data, it could be your data is kind of irregular, or maybe with the zigzag patterns, we can classify it as a random variations, or in the simple term we call it noise variables. What is the meaning of noise variables? The noise, it could be combining about the certain and uncertain or unpredictable data between your data analysis. So how to measure about our accuracy, the accuracy of our data. The accuracy of data is reporting like the forecast error using the absolute error, the root mean square error, and the mean absolute percentage error. But whatever you choose is no problems. There is a different analysis, and they are accepted using the absolutes, the root mean, or maybe the mean absolute. A sum forecasting software package, if using a software, it's minimized using the absolute and root mean and the mean absolute. So they are very uh, comparisons about the measures and about the regression equations. So there is no guarantee where is the best accuracy, but you can use with the one of the three options. In your kind of data, you need to test about the randomness of your data and the model. The randomness of data is containing about the fit value or the settle value and the residual value, including in your models. The calculation comes from the past data and supporting by the available information in your modeling. So the fitted value, it could be separate with the residual, because the residual is sometimes unstable. The number of residual is unstable, or we call it the error of data. But the fitted value, it could be predicted in our analysis. The noise is included in the residual of value. So if you find about the data like this one, this is the common non-random pattern, like the series, this one, the series 1, the series 2, or the series 3, and this one for the series 4 is very, very random. But we cannot know about the pattern. Sometimes we could be in a downline trend, but we have the graphical cycle between this one. So how to ensure that our data is random or not, you need to create about the run test. The run test is about the quantitative methods to test about the randomness. Next week, we will apply about the run test using our statistical. But today, we only define you about the descriptions or about how to test or how to obtain about the test about the randomness and relationship. So the run test is only tools using the quantitative data to ensure that your data is random or not. The run test is also predict about the autocorrelation of data, because we need to make sure that your explanatory variable is not correlated to the others. There is the basic functions or basic rule in the regressions. So the regressions is based on the trend model. So it could be in upward or downward, but using the exponential data or using the more than one of explanatory variable, it could be used for predictions. The common trend of the regression analysis is using a linear trend. That means that you have the time series data or time series variable is changing by the constant amount in each time of the period. So for the interpretations, it could be for your sign of your beta. If your sign is positive, it's an indicating that your trend is an upwards. But if your beta is negative, it indicates that your trend is a downward of pattern. So be careful about the sign of the beta. The beta is here, so we need to find the sign about the beta. If the beta is positive, it should be in upward. But if the beta is negative, it could be in a downward trend. So the upward trend is like this one. The downward trend is like this one. That is for the linear trend. If your regression analysis is concluding about the exponential trend, we also graphic about the analysis or forecasting, but not in common regressions. Sometimes we using the logistic regressions or probit regressions for the probability, but there is no linear regressions for this one because the exponential is could be some of your data is predict in more than 200% of the predictions. It cannot be measured clearly because they having the random walk or the random of moving average. Yes, the random walk is the kind of data that include in your exponential analysis. This one is the kind of the random walk. You cannot predict clearly or measure uh, the existence of your data. It could be that is upward trend or downward trends. You cannot predict directly. If you're using a but moving average model, that's also good, but there is the term in average of the span analysis, not in the long run analysis, just in the small view of the analysis. Like this ones, you need to cut about your analysis, not in the high trend or in the long run trends. You need to cut in the short trends, like this one. Maybe for this moving average, you need to cut in these periods. We have the upward trends. It's also this one, we have the upward trends and we have the upward trends too. But the data in here, inside this one, is cannot be concluded. If you find about, take the data in here, it could be in a downward trend. So be careful about your moving average. It could be misinterpreting about the span of the data. Okay. What kind of analysis or what kind of the forecasting methods using the exponential? You can use with the simple exponential smoothing. You can use about the Holtz method or the Winter method. But the kind of this analysis is very strictly to the statistical process. But this is not our parts about the analysis in here because we only using but the simple models or using the simple exponential data or with the simple regression only because we have the lots of data in the fintech and data analytics and we only using about in general terms. We only in the uh, previous or in the new comes for the data analysis, so we can make the analysis using the trend, using the pattern, using the regressions in a general term or in the very simple analysis to help you to make some decisions or make some prediction using your public data. Okay. The last is maybe for the seasons model. The seasons model is kind of the regression analysis that could be coming back or turning back again, but in the kind of series, in the different series. You need to creating about the decisioning of data, cutting your time analysis data, and classify into your different category. So it could be in the winter models or maybe in the calculations of data like this one, or using the ratio to moving average method. But it's the similar methods to predict about the linear regressions or the analysis like this one. You need to cut about the period in the period of upward or on in the period of the downward. If you can cut the period, you can make the general analysis using the average, using the regression. That's upon of you. But we need to know about the cut of the period of the analysis. Okay, I think that's all for our materials for today using the relationships. Use you learn about the regression analysis and also to estimate about the predictable and the unpredictable variables that could be using for your forecasting. Okay, any questions before we close the sessions tonight? Diane and Norlin?
Answer.
Thank you, Diane, for responding. Okay, none so far. Next week we will continue about these materials. I send you in your emails the materials, but the next week we only calculates about the how to obtain in our analysis using a software, maybe in Excel, SPSS, or in another. Okay, what is your question, Norlin? Can write on your chat. Okay, you don't have any questions. Okay. Okay, thank you for coming in the class tonight, Norlin and Diane. I will send you about the recording of our class today. And next week, we will see you again in the class in the same time of the class sessions. And we will, okay, no problem, Diane. And we will learn about how to obtain the analysis using the regressions in our familiar or common software. The audio is a bit choppy. Okay, no problems. Okay, thank you for coming tonight. See you next week, and good night for Norlin and Diane.